Section 7.2 RA-2, the mean incubation time of fertilized eggs is 24 days. Suppose the incubation times are approximately normally distributed with a standard deviation of 1 day. Determine the 13th percentile for incubation times. So the first step is to draw a normal curve and shade the area corresponding to the 13th percentile. The 13th percentile means that 13% of the data is less than the random variable x. So we want to talk about the area under the normal curve to the left of x is equal to 0.13. So let's first talk here. We know that the area is equal to the 13th percentile, which is equal to 0.13. And so we're going to draw our picture, our bell curve, so we can get a clear picture of what's going on. So therefore, what do we know the mean is? Well, the mean is 24 days. So we know that the mean is 24 days. And again, the 13th percentile means that 13% of the data is less than the random variable x. So let's take a look here. We know that the random variable x is going to be located here. And this area here represents the 13%. And so that area is equal to 0.13. So what we want to be able to do is we now need to find a z-score corresponding to the area that's equal to 0.13. So we're looking for a z-score. So that means we're looking for the area of 0.1300. So we got to come down and then take a look at all the areas located in here. And we want to look for 0.1300. So let's take a look. We got 0.13. Okay, so if you take a look between these two areas here, okay, these two areas are showing, maybe I can highlight that a little bit better here. So we'll highlight this. So we're looking for 0.1300. So it's in between these two values. So it's negative 1 point, either negative 1.2 or negative 1.3. So we need to figure out which one is it closer to. So let's take a look at those two numbers. Okay, so we're going to take these two numbers. Okay, and then we want to figure out, okay, which one is it closer to? Okay, so let's see here. We know that, again, we know that 0.1300 is in the middle. Okay, so what is the difference between those two? Well, if we take 0.1314 and subtract 0.1300, the difference there is 0.0014. Okay, and then what is the difference between those two? And so the difference between those two is 0.0008, which means it's closer to this value here. Now recall that the z-score was negative 1.1, and this was 0.02, and this was 0.03. So therefore the z-score is going to be negative 1.13. Okay, now that we have found the z-score, we can then find and determine what the value of x is, because we know that x is going to equal mu plus z times the standard deviation. So therefore, x is going to equal the mean, which we know is 24, plus the z-score, which we know is negative 1.13, times the standard deviation, which we know is 1. And so when we go ahead and calculate all that, we get 23. And so therefore, we can say that the incubation, or the 13th percentile for incubation times is 23 days. Okay, now we can also solve this problem by using technology. So we're going to use now the TI calculator. So let's use the TI-84 calculator. Okay, so what we're going to use is we're going to use the function called inverse norm with the area, the mean, and the standard deviation. So what we want to do is we're going to use I and V and then norm on the calculator. And we know that the area that's given is 0.13. We know that the mean was 24. And we know that the standard deviation is 1. So let's go ahead and put that into our calculator. So if we put that in our calculator, in order to find I and V norm, what we're going to do is we're going to go to second and then distribution. And then we're going to go all the way down to number 3. And then we're going to put in I and V norm. And then we're going to put the area first, which is 0.13 with a comma. And then the mean, which is 24 with the comma. And then the standard deviation with 1, and then close the parentheses. And then equals. Okay, so let me go ahead and copy and paste that. So when we get this result, you can see that we get a value of 22.87. But we need to round that to the nearest whole number because we're talking about days. So therefore, we would round this to 23 days. And you can see how quickly we get the answer that we got over here. But it still is important to see how we go through each step to go from 1, 2 to be able to draw the area and everything else. So this is using the TI-84 to calculate the value of x. Okay, and now let's also do this using StatCrunch. So if we wanted to use StatCrunch, then this is the following. Okay, we want to find scores corresponding to an area, which we're given an area which is 0.13. We're going to select Stat, highlight Calculators, and select Normal. So let's go to StatCrunch. Okay, and so what we're going to do is we're going to go to Stat, we're going to go to Calculators, and then we're going to go all the way down to where we see Normal. Okay, so now when we see Normal, it says enter the mean and the standard deviation, and then so we're going to enter the mean, which we know, which is 24, and we know that the standard deviation is 1. Okay, and then it says in the pull down menu, decide if you are given the area to the left of the unknown score or the area to the right. Well, we want to find, we're talking about the area that's to the left. So we want to find the area to the left of that value. So what we're going to do is over here, the area that we have is 0.13. So when we compute, you can see what we get. We get this entire picture, and we get the same value that we got on our calculator. So let's take a look here. So by using that information from StatCrunch, we can see that we get the same value for x, because we know it's got to be less than, right? It's matching our graph that we have up here. And so here we can see that x is also going to equal that same number rounded to 23. So that is another way of using technology. But again, like I said, these are good ways to be able to, go through the problems pretty quickly, but you need a general understanding first before you start using technology.